guys, so you can see a big scheme behind me. So this is a simple schematics that I've made for a battery charger. I found somebody looking for a battery charger repair, and he asked for a circuit diagram of it. So I made it specially for him.
Where did he ask for?
In the electronics group.
Okay, in the group.
Okay, the
You are part of the group? Member of the group? Okay. So somebody asked a question about battery charger circuit.
How to make a battery charger.
So you created this for posting in the group?
Yeah.
Okay, this is great circuit and very complicated. How long did it take?
15 minutes.
My goodness, it is good. And can you explain what this circuit does and what have you tried to represent here?
Okay, so just give me a pen. I'm going to explain it to you. Okay, so here I have this blue pen. So this will connect to your power.
Power means?
Your AC in. Your AC
this is
in
220
comes
volt
here.
in.
AC in that goes through your.
What is here? What is represented by this?
It's electromagnet that has a specific thing that is that specific magnet that it creates magnet here that passes through the secondary and creates more voltage there. So this is iron core. So these two lines represents iron core. You can use ferrite core, doesn't mean you use this. You can also use air core. Just that you want to convert.
It's a transformer?
Yeah, it's a transformer. Okay, so first of this step is 220 volts. You have to convert to 14.5 volts. No, 14.4 volt. That is okay for batteries. For charging, the
Transformer will convert 220 to 14.5 volt.
No, 13.8 volts.
Is it AC or a DC?
AC.
Okay, so it is still an AC after
It goes
transformer.
through a rectifier that converts the voltage like this. On scope I've already written. This
on
is a
scope you check it.
capacitor. So
It will show up as a
Yeah.
sine wave.
Yes, a sine wave. No, it's just like dumps.
Okay.
It converts like this. Like here, this it creates up. This is already
And what
up,
is this?
And this.
RF.
RF means rectifier.
Oh, after you have rectified it, so it becomes like this.
No, it doesn't become like this. It becomes like this.
Okay. So it becomes becomes a DC.
No, it's not DC here. It's not.
It is
DC.
not yet DC.
It is not yet DC. After the capacitor, it comes like this unknown DC. Can you just bring the cam close? Like this. When it comes, this goes down, and this, and then this, and then this. Actually, the voltage is like this.
Okay.
See?
Then how do we get a
Then
true DC?
It like these, like these, like these, like these. It goes like this forever, infinity, you can say. And this is on scope, and then it goes through a rectifier, and then the voltage comes close to DC here, as you can see.
So what for you are using a resistor here?
Resistor for preloading this capacitor, and when they have switched off the power.
And what for is the capacitor here?
For
Preloading the
filtering,
capacitor.
for
For filtering.
And when this is cut off, then this resistor will slowly discharge the capacitor.
And why you need to discharge the capacitor?
Because then if you short the output, ding, explosion will happen.
The output.
Yeah, the output.
Output of DC, in case it gets shortened, even after the DC power supply is off, it will.
What? Okay, so then we again make a power here. It has again come AC power, and then the
And what is RG1? Where is RG1?
RD1 you can search here.
Oh, here
Regulator.
regulator. What
This
for
is
is the regulator?
For regulating the output voltage to around 13.8 volts.
Okay, regulator is a potentiometer.
No, it's not a potentiometer. It is actually called a transistor. It is called a transistor, like LM78012. You can use it. That will not charge the battery that high rate, but you can use LM8014. You can use that will charge it perfectly.
And what this R1 register, what is the value of this R1 register?
Any resistor.
Any.
Yes,
Just to
any.
discharge the capacitor so that the output is
preloading
not
the
shorted.
capacitor. And preloading the capacitor.
Okay, and when you write T is transformer, where is T? Is this the T?
Yes, this is transformer.
And this C1 is what? What is written? 1000 microfarad, 35 volt. And where is C1? This one is C1. And you posted it in your group, electronic project group?
Yeah.
Maybe you can invite Harjas also there.
Ah, sure.
Send him the group link. You all can talk to the big guys there.
Oh yeah. Okay, anyway, so now
And do you have the link for that group
I have
where you talk to? And all the people, they are nice and friendly.
yeah, there.
They answer
So,
your queries.
Yeah, now I will also make a 101 series now, and then we're going to see. Today's 101 series will be based on.
But that group is for big boys, electronics engineers.
Yeah, so that 101 series you can also find in that electronics group. Link would be provided in the description.
Okay.
And so for now,
Who
my
can build
101
this?
series-
What should be the prerequisite for building this?
Prerequisite transformer, rectifier, wires.
These are the
capacitor,
components.
regulators.
These are the components. Skills required. What are the skills required?
Using iron, soldering iron.
You should be knowing how to use the soldering iron. And what else?
Soldering iron.
You can build it on breadboard.
Yeah, sure.
You can build it on
But
breadboard.
on breadboard, I highly doubt you can put the transformer on the breadboard.
Hmm.
So that,
Okay. But what is the recommended age for making this?
uh,
Because here you are
age
doing.
is plus 16. Plus 16 is the age, but
But here it is 220 volt. Huh?
Yeah, so be careful. And
You
yeah,
remember that person who came to our shop asking for the power supply charger, battery charger for his remote car? He can build one for charging his own car.
Yeah, it's far more cheaper to buy it because this is not switch mode. This is just a prototype and it is not switch mode, and buying these all components is very expensive.
But then why do you do it? When buying these components are very expensive and you buy components worth 750 dirham that day. So why do you do that?
Because I want you to learn how to do it.
Okay. So just for the sake of learning, even if it is expensive, you should make the project.
Yeah, so this is, but now this is not, I don't recommend this circuit diagram because now we have high frequency transformers, and then we can use switch mode that converts AC to DC, then to AC, and then finally to DC. Why? Because when we convert it to AC in, then I convert it to DC. Because they want to make high frequency AC then. So transformer size will be small and it will be more efficient.
This is why SMPS are used more in computers for accurate DC.
SMPS, and that stands for switch mode power supplies. And regulated switch mode power supplies are known as regulated. I will write so you don't forget. Regulated SMPS. RSMPS we call them, means regulated switch mode power supply.
Would you be posting a schematic diagram for regulated switch mode power supply also, or would you be making one?
No, it's a switch mode power supply. They need tons of components for that.
And why don't you buy it? Do you want to plan to buy those components?
Yeah, I have some of the components like S914 I have, 13001 I have, and I don't just have those high frequency transformers that after I complete this.
So do you need to buy those components?
Yeah, I need a high frequency transformer and that's all I need.
So are you waiting for some muhurat?
Huh?
Are you waiting some muhurat to order those components, or when would you order?
I just need a voltage regulator for completing this circuit diagram. I have made it till here, but now when regulators will arrive, then
And what was the opinion of the big boys when they saw this circuit diagram? Did they laugh at you?
No.
And what kind of stupid bacha diagram you have given? Like that?
No.
What did they say?
They said, yeah, this is not that understandable, but still it is understandable.
So you are playing with the big boys now,
Yeah.
and you say it is to be recommended age for making it is 16 years. And how old are you yourself?
8 years.
Huh?
8 years. But I have the capability to make it, because I have touched the 220 volt line, so I know how dangerous it is. So I do it at my own risk. So you also do it at your own risk, not at our risk, okay? So if you want to do it at your own risk, not at our risk, okay? Dangerous, okay?
They must go step by step. First, they should play with ready-made power supply,
Yeah.
not exceeding how much.
They should first do with ready-made power supplies.
Ready-made power supplies they already have. They can take a power supply of their phone, their mother's phone. They can steal, and power supply they can use for lighting up LEDs. What is
And
the
yeah,
problem?
you can use your computer's power supply too for charging your laptop. You can
So
borrow
there are
it.
lot of ways to play with electronics.
Yeah, there are.
One has to be curious,
Yeah.
and my idea is borrow,
Borrow and then return.
bag, देना यार please देना, bag, borrow, अरे दे देना थोड़ी देर के लिए. If they don't get by begging or borrowing, then steal.
Oh.
But do experiment,
Yeah, we'll do it.
have fun.
So yeah, but again, I want to tell you, we have mains AC here.
So
Okay, so yeah,
16
it
year
is-
plus.
It's 16 year plus, and it is safe at the. It's not safe at the input, but it is very safe at the output. You can touch 120 volt DC too.
Okay.
Yeah, you can touch it.
When are you
It
going
will
to make
just-
it into production?
Production, I feel I will do like 20 years.
Okay.
Okay, so guys, just a second. Okay, so you can touch 120 volt AC. It will feel a little tingle at your screen, but nothing will happen bad. And again, I hope you enjoyed. And
दूसरा बनाना, when you make another circuit, then show them how. Do you have the power supply now? Can you show them?
yeah, come.
Yes.
Okay.
Are you going to show us the power supply now?
Yeah. So it is just lying around right here, and here it is. And yeah, I just keep all my power supplies and transformers right here.
Okay.
And
So here you will give 220 volt, and here you will get the IC. And what for is this?
this is for regulating.
So
that.
this is based on the circuit you gave.
Yeah.
You showed there, right?
Yes. It is approximately the same circuit, but
You
not
can
exactly
run
the
something with this,
same. Yeah, sure.
light up something or make something move.
Yeah, just give me some. I have some LEDs here, some constant current LEDs. So
Why don't you run a motor?
No, I just for now run this LED.
Okay.
Here's the LED. No, this is 220 volts. 350. No, I cannot adjust it to exactly 100,000 milliampere. But 700 milliampere LED will also work. Just I will not increase the power full. I'll just increase the power here to here, so it doesn't blow up. Okay, so here it is. Just this extension box is coming, and I just turn this off. This plug is a little short though, to my taste. Okay, anyway, this wire is now getting tangled. Just a second. And guys, it doesn't also help that I kept the input AC wire close to the DC wire. So what will happen that the AC magnetic field will interact with the DC. Anyway, it still works. Bam, it works.
And what for you have used the fan here to cool down the power supply?
Yeah, and it blows very cool air out of the other side. I use this for air.
This is the real application
That's it?
of the power supply circuit that
Should I
we showed.
brighten the light now? Whoa.
My goodness, it is too bright. And
Well, how is the camera recording? Yeah, it's so
Come karo
bright.
isko. Come.
Okay, I can do it. Cannot even see directly in the light, is it all?
Yes, it is going down.
So guys, this is the LED. This is the you can also use it to charge a battery. Yeah, sure. Charge it to and this I actually made because my old that one has been dead, my old battery charger. So that's why I made.
So this power supply you have made based on that circuit. Anybody can make it, right?
Yeah, anybody can.
Okay, good, great.